So very quickly you guys have to start talking about, okay? As I said that it will be much more two-way instead of in one way, because the whole thing, you don't need to believe that whatever I'm saying this is, because I'm not the scientist, but I know some way how to deal this part, but that's not the only way or unique way, or this gives the science back. Okay, so we have to understand that part. But some of the things probably, as I said, that you can try to understand what the complexity might arise in different type of data set, and which is the kind of the commonality in many of the other data set, whether we'll be talking or not talking. The characteristic is the same, like for as I said, that the functional data, image data, high dimensional data, those characteristics would be there. So where we like to go, that try to introduce some of the technique, at least which are accepted from the machine learning and statistics literature, that this could be useful technique. So that part will be introducing. But then still long way to go, whether how the way used to that techniques and it really gives meaningful science or not. That's we have to solve problem by problem, data by data, case by case basis. So where is your friend? So we're talking about this fMRI. Then just as a completeness, you might see again, this is the slice of the brain. You might see differences when you are listening, when you are under the speech. What does it mean? As essentially, these are kind of the different region of the brain. As I said, that most of the part of your brain actually is back home. There is nothing. And when under the speech, this part of the neuron, it may represent one of the neuron, may represent a cluster of the neuron. They are kind of firing, what we call in medical science, or it's firing versus not firing. Under the listening, you can see that it's different, it changes. So given the different task, the different part is these things are changing. So that's the reason is that why people like to know the brain from the science perspective, that particularly the different diseases like Alzheimer's, Parkinson's disease, these are all kind of neuron driven. If we can identify the portion of the brain, really early stage of the disease, neuroscientists can concentrate over there and try to see what is going on. And at least you would know if the other parts remain intact, then what are the other symptoms might happen or may not happen, all sorts of things they might be able to say. But the issue is that, as I said, that still in early stage, probably I will give that example, that the data, when I cannot handle that 1 million neuron, essentially what we measure, the volume of our brain. So why this volume of the brain sometimes useful? Volume of the brain also something like your volume, my volume are may be different. Typically, for the Alzheimer's disease, the brain volume usually sinks. The people become more Alzheimer's, then brain volume sinks. Some cases significantly sink, some cases it is not. That's kind of the medical hypothesis, as I said that. So to identify whether a person progressing to the Alzheimer's disease or not, how do I do that? At least if from this image, if I can measure the whole volume, then for the disease and the non-disease, I can do some test, and simple t-test could be useful even. So from the statistics perspective, it is no big deal, oh, you are doing the t-test. But before I kind of conceptualize the whole problem, nobody knew that you can do the t-test. So that kind of the test, but as I said, that as the way technology is improving with this very high resolution fMRI scanners are there, you can really identify each of the neurons. So the natural curiosity is that let's look at what's happening at the neural level. But problem becomes, then it's a huge data, how to deal with that, and your number of sample size may be still might low. So for example, there is a big website you might look at, ADNI, Alzheimer's disease neuroimaging website. It's based in Southern California, University of Southern California, Department of Neurologists, which are archiving all this brain data. Still there would be about 1,000 patients they have, like 1,000 individuals who kind of potential to be Alzheimer's, but 1,000 patients, right? But note that for each individual is generating this many data points. So in some way, if you like to model, actually your model has this many parameter just from one individuals. Then if you have 1,000, then 1,000 times of this, you can think about this way. And from mathematical standpoint, with our existing or whatever you have learned so far, the statistical tools cannot solve this thing. So that's what some of this technique we have to learn, but we are doing. Whether eventually we solve the problem from scientific perspective or not, that still do not know, but at least we can actually handle that data at the neural level. Okay? So again, all this thing, we will handle this thing from the perspective of what is called the high dimensional data. So how to handle the high dimensional data. And there are many ways, but one thing I just was talking to him and he said the clustering, because we also can, since we cannot handle the whole data set at the same time, you can start thinking about there are some clustering structure. But again, doing this clustering is not really k-mean type of clustering, usually would not work, because there is an adjacency factor, the structural adjacency between the neurons. So you cannot just partition like this, or you cannot like partition this, or you cannot just toss a random coin that here is the partitioning thing. So typically what we call the spatial partitioning domain. That's the way same phenomena goes if I like to capture the whole climate data over the whole earth, because it's a big, and the climate changes continuously. So you cannot just cluster using the k-mean clustering type, because that really does not give you the right answer. So you have to find that there is a conceptual change of weather. You have to find that point probabilistically, and then you can do some clustering, and that might help you. If you do the clustering, it helps you to deal the data better. Still, clustering does not really give any inference, like you like to estimate the mean, all this thing, it doesn't do anything. But it helps you to deal the big size of data piece by piece basis. Okay, so then as I said already, that one can think about the it's a network. Sometime people are looking about the region, like this is a region, sometimes we call the region of interest, ROI. The region, this is the region of interest, this is region of interest, different regions, and you like, so for example, Alzheimer's disease, it might happen that only this region might be affected, all other regions are not affected. If that is medically true, then what we can do, we can just take the data related to only this portion and just see what's happening there. So that is also, but that is again, still it is controversial. Some of the neuroscientists think this is the portion, some of the neuroscientists say, oh well, this is the portion we see, but hey, these are kind of the network, so unless we see the other part, and if we just concentrate here, that analysis may not be right, because brain is a network. So what if you just break the data, that may not make scientifically right. There might be some scientists, you might see that they are agreeing with you, some scientists may not agreeing with you. Okay, so we had actually enough number of data. One more data I think I might give, and then we might proceed to a different thing. So is there anybody from mechanical engineering here? Nobody. Can anybody identify what is this picture is? It is behind the spinal cord, right? So what happens when people go beyond age, say 60 or so, there might be a growth just behind the spinal cord like this. And this is not a very well shaped you can think about tumor, but it's not like cylindrical, or it could happen like this. It very asymmetrical shape it can happen. But idea is that usually it grows over the year once that anybody get that disease. It's typically what it call that abdominal aortic aneurysm. So what is the medical term is the aneurysm. Okay, and about 60% of the people, 6% of the people usually might get affected with these things. Now, from medical perspective, in general way, if that aorta gets 3 centimeter higher, the diameter is more than 3 centimeter, then this could be a dangerous thing. But this is again very vague statement, because if you look at the shape, 3 centimeter from where? In the middle, it kind of the bigger. In the top and bottom, it kind of the smaller. So it's not really very nicely thing. Okay, I'm the engineer, I can go and measure this thing. No way. Okay. Not only that, this is, we all know, this is the organ of our body. So the cylinder, it's not a bottle that every time the thickness is everywhere the same. So the thickness here changes depending on where you are. So somewhere the thickness of this thing is bigger, thickness is smaller. So the measuring diameter could be very questionable thing. But still, how the way they do that? Basically, you do the CT scan and take the CT scan, and from the CT scan you try to estimate what is this diameter would be. So there is some estimation error, but that's the statistical part. So essentially, you look at this image, try to draw something. So one way is that you can conceptualize the whole thing like this type of cylinder. If it is a well-shaped cylinder like this, and then you are pushing a ball through this cylinder, and then as the way ball moves, you are kind of drawing a center line, and then from the center line you are drawing, kind of trying to measure what the radius should be. But that is again, it's from all image and all we are doing very imaginary way. But that's the only thing we can do. But still, now the big story is that truly physically you cannot send the ball, right? Because you can just take the image. So what's the in mechanical engineering, what is called, it's a computational model. So what the computational model does, without having this image even, they solve like 1,000 differential equations. Okay, anybody has done any work with computational models? So basically, I don't need to know you. You just give me your description. I can run my machine, which will take probably a month long to solve these all equations, because I'll put some parameter values about you, and it will structure you. That's the way it is. So for this disease, there is a computer model built up in Berkeley lab, University of Berkeley lab. It was originally built up, but now it is available pretty much everywhere. And using these differential equations, actually you can create all this hypothetical way, and you can get this measurement, all sorts of things. And once you have this part, then what they do, they generate this type of measurement for number of like year 1, year 2, year 3, and then try to predict year 4 using all the computer model. But think about computer model is just a computer model. There is no data itself. So when the patient comes in, actually you can get the image, and we already talked about how to, or there is a way to extract the data from the image. So if I get the image, idea is that can I have my that computing model, whatever we said that the mechanical engineer developed, because that was no data, so it's predicting basically without anything, without any data, they are predicting something which may be right, which may be completely wrong because they did not observe anything. But when the patient is already into the hospital, then I get this data. How do I use that data into the computer model and make a better prediction? This is called the computer model calibration. So this is another big area of research, modern research, which involves the computing, and then of course it also generates the big data. So what the way it generates the big data, because since it's the computer model, and as I said that you can create this radius, but since the computer model, as many radius you want, you can generate. So infinitely many radius actually I can generate. And conceptually, you try to generate that as many data as possible. You think that that will make your model better, but actually it might kill your everything. The reason is that when you are generating this type of data, you did not look at the patient. And then when the patients came in, you look at this one of the image. But if you generate too much computer generated data, then this computer generated data dominate the whole thing. And you know that if you calculate the mean, then the mean would essentially come mostly calculated from the computer generated data if it is too much. Unless you kind of do some kind of weighted average type of thing. But how do you do this weighted average? All sorts of questions arise. Okay? So that's a big challenging thing if you are working with a computer aided modeling, because oftentimes you heard about it's a computer aided model or computer models. But there is a big problem if you just work with a computer model. So if you have the real data, then how to, but at the same time you don't like to completely remove these computer models. But then how do I combine these two things so that I can get a better prediction, better decision making? So this is, as I said, that this is another good area under this data science, big data problem. But if I get a time, then I'll go to this data set, otherwise I won't. Then I have, so number of examples you got about already, not only the big data, I'm also talking about the complexity of this data, right? There is another data set, but I think I'll stop it here, the spectral radiance change studies in the climate. So typically, in short, so how the way, who has the idea how to measure the climate data? Like we are talking about Delhi is a case study essentially, but what is happening? If you take the air 1 cubic feet, say from Kanpur, and 1 cubic feet in Delhi, you will see the difference, right, in terms of composition of the air. But what does it mean that 1 cubic feet? When you take here, we know that the physical differences are there, right? But this density changes as the way altitude changes. Like whether you are taking, say, 1 mile above the ground, or 2 miles above the ground, or 3 miles above the ground, and in this way you could go as much as you can. But it's a continuous changes. You can just measure only in different level. Same way you could do at the Delhi. But overall, if you now look at the whole sphere, essentially there are changes as the way you moving from one location to the other location in this direction, right? And then as you go to the altitude way, then there is another layer, continuously it is changing. From level 1 feet, 2 feet, 3 feet, you just measure in a discrete fashion. But essentially it's a continuous change. You cannot do continuous measurement. You are just taking in wherever your scanner is or the satellite picture is there. Oftentimes you take to the image, or oftentimes you put that weather station, and weather station wherever it is focusing, right? But the complexity is that it's a continuous changing density of the air quality, and which you need to capture. So one of the study, what is going on, that out of this kind of 10 different, although I cannot explain what are these different atmospheric cloud properties, temperature near surface and skin, surface minus 200 HPH, water, vapor, all sorts of things. Essentially it measures the air quality. Okay? Typically there are kind of 15 air quality which is changing continuously over the regions and over the height as well. Then there is another complexity. It's over the time. You guys have seen that in January, December, January could be the worst. So over that there is a time factor as well. So how many dimensions are there then? Actually in physical way it is 3 dimension, because x, you have to put any location x, y, z direction, and then over the time. The 4th dimension way, but every dimension it is a continuous changes. Okay? So typically when you from the satellite you get the data, and then you try to measure in everywhere what is this strengths are, and try to eventually come up what should be the air quality. So the data structure would be from January 2003 to December 2004, which means 24 months. Every month it's kind of, again, this is kind of discretized, as I already said, it is the discretized data, but actually it is continuously changing. January to February, it's not your salary, what was, or your income January is this much, it's not like that. It is a continuous changes. You just observed in February, you just observed in January. In between, you did not observe. So when you are handling this type of data, then this is the top of the atmosphere. You are dividing from 50 to 2760 per centimeters compare. So each centimeter resolutions, you are breaking this point. So you are observing the basically every 1 degree resolutions. That's what, so that creates about 2711. And then from the latitude, that means from South Pole to North Pole, minus 85 degree to 85 degree, that in every 10 degree, that's the way you breaking the whole pieces. So that means how the way I can see that this world surface, you are making number of rectangulars, and then over the things, basically per degree resolutions over the top of the air, you are breaking it up, and that's the way the whole data is coming in. And then the data size, that's essentially it goes 24 months and 2700, oftentimes you call that frequency, like radio frequency type of things. That's what this 2711, and 18 is I think from North Pole to South Pole, and 16 is from this other direction. So that's the way, that's time point, that many points you are observing, but all are in a continuous surface. You are just making a discretized way. So that's nothing to do on me or computer scientist. That's whatever the geographer suggested or the climate scientist suggested. This is the way you take the data. Okay, so that create about 18 million data point. Have anybody handled so far 18 million data point? You like to do that, right? Yes. So this type of data are now pretty much people are interested in to look at. So how the way, one thing here is 3 things are there. In general, again, there are many different way, but what we tried to look at essentially, one of the that's the clustering thing you mentioned. That's what I'm mentioning. We tried to think about that, although it's a continuous surface, continuous top of the air, but we can somehow conceptualize clustering the whole thing. Like cluster wise it is same, between the cluster it is different. But that cluster changes would be kind of under a probabilistic model, like with probability 0.6 there is a break. So which means that I'm not saying that there is a clear partition, but with probability 0.6 there is a partition. That's the way whole model I have some uncertainty measurement. That means if I'm wrong, I'm saying that how much percentage I could be wrong. I'm never claiming that I'm the completely right in that sense, okay? So then another thing is that whole data actually we look at is as a functional data, because as I said, it's a continuous one, but we just observed at different discrete point, but otherwise it's a continuous thing, because everything again it comes from the image, because when the satellite takes the image, it's a whole piece of like just image, then you break it up in a different point. So it requires the clustering, it requires to handle clustering of the functional data. That's why this high dimensionality issue is coming. And also the characteristics of the air quality changes from one cluster to another cluster. So if you have a model in one cluster, that model has to vary in the different cluster. As a result, although you did the clustering, your number of parameters still could be huge, because you are assuming the characteristics are different for the different clusters. Okay? So again, this is how the way I can solve the problem. But what I want, these are very complex big data problems. You guys do whatever the way you like to do. And then you say that this is the best thing. And you talk to the scientist, because I won't be the judge for your analysis. The climate scientist would be the judge for your analysis, whether you are doing the good thing or not. Make sense? Okay, which data now you guys like to work? Think about right from the day one, you just dig into anything. So I'll still talk about some of the other data sources. Either you dig into one of the data, or you think about any of the problem. It should be fun. Otherwise, if we don't do anything, then what would happen? It's just like I'm lecturing in another class. There is no point. So far, so good, right? Okay. So here is this problem solving thing. Some of these data size I got actually from the Square website. This is, I think, mostly based on Indian site. You know, right? Some of you know about these things. This is also lots of free data set. One of the thing is that is a good data science project. So you pick up any one of these things, or we'll talk about some of the other things. Market analysis. What will I buy next? There is a 3 million Instacart orders open source data. So use this data size. There is only one question. So that means each individualized way there is the records are there. What will be the next buy? If you can predict, you'll be the CEO, right? But do it. As I said, that nobody knows the answer, and nobody has all the tools. I know few more tools than what you know. That doesn't mean that I know the best solution possible. So on the other hand, a simplest possible solution could be the best solution. Even if I use that high level clustering, high dimensional thing, it may not mean, because everywhere there is assumptions there everywhere. That may not mean that it will give you the best solution. So in my experience, what we have done, I think probably you guys also have seen, if you have used the Amazon, you buy one thing and then the next thing come into these things, right? And what would be so there would be 3 items, right? What would be the first item, second item, third item? Do you have any idea? Or why there are only 3 items suggesting, why not 5 items? You have seen, right, this type of picture. Do you know any idea about that? Because all again man-made algorithms. It's not that this was God-given things are coming next 3. For one item there are 3 other items. not like that. Any idea? There are many algorithms are being developed in everyday basis. So first thing, why there are 3 items. Sometime, again, every company does not use this way. So, but you can probably agree with me. So first you make a list of the related items. So for example, if I buy a phone, immediate things comes accessories. You buy this cover, you buy this power plug, this extra battery, this type of thing, right? So you have a list of accessories, 10 list of accessories. Then you calculate the probability of its necessity with buying a cover. So if you buy a iPhone 10, you probably would think about immediately first the cover rather than the battery, because iPhone 10 is so expensive, so you may like to protect it better. So in that case, they calculate first the probability of the importance for each of these 10 items, and I'll put that first item, the item first, which has the higher probability associated with my purchase, then the second probability, the third probability, and probably I'll remove. And in some cases, there is probably only 2 associated items could be useful. Other items are not used. Then I'll just put 2, and then if they're equal probability, it doesn't matter. But if one is the higher probability, I'll put that one first, and then the other one is the second. Another way Amazon does, which was one of my students' project, use the network. So whenever you talk about any book, say for example, I'm talking about a book on big data. So then you can actually make a network. So that's kind of your one of the node, and then you attach number of node big data. So say one is the parallel computing, one is the Python, and one is the statistical learning, these 3 books. And then so if you attached all these other nodes to your main node, then you can calculate the edge and actually you calculate the probability. What is the connection between this, or some other way like covariance matrix, you use inverse covariance matrix. There are many different ways. So basically, you try to estimate the probability of connection between your target node to the other associated node. And then you put those things, the whole network, once you buy this product, the whole network come in as a prospective next buy. Okay? So yes. So yes. So that's what the network analysis comes in. So what is the network analysis means? So basically, I should be very simplistic thought is, if I can think about the network is a matrix, very simplistic thought. Typically, under the Gaussian assumption, it's an inverse of the covariance matrix of the Gaussian probability distribution would be the network. Now, if I can estimate the whole covariance matrix, then I know all the probability for each of these things. So again, there are some assumptions are there. So some of the tools probably we might talk, but again, these are the existing kind of the solution, or we kind of can think about. But in a reality, it may or may not match. But oftentimes, if it is a reasonable assumption, it should work. For example, if the Gaussian assumption does not work, I really cannot express the network as the inverse of the Gaussian covariance matrix. Theoretically, this is mathematically wrong. But mathematically, I can prove that if the purchase data things follows a Gaussian distribution, then the inverse of the covariance matrix can be represented just your network. So that's why the whole big covariance matrix, if you go to the big data literature, big covariance matrix estimation is a big issue, and computer scientists, statisticians, mathematicians, everybody behind that, how to estimate big covariance matrix, because that is one of the key tools for network estimation. But if it is not Gaussian, things could be a lot more complicated. Okay? So, go ahead, start doing this thing. Amazon review for the sentiment analysis. Anybody has any experience sentiment analysis. Few millions rows of Amazon customer review text and star rating. So how do you analyze those things? Again, I'm not expert of the text analysis, but some of the tools already you found that could be useful.
Maybe
You can do, but first thing you have to read the data. First, how to, because it's a text data, how to read the data. So there are many different ways. One way, actually, those who are good in image processing, you can think like in the zip code analysis, what we did, we try to recognize whether it is a 0 or it is 1 or 2 or 3 or 9. Here you try to recognize A to Z, A, B, C, D, and then put up. There would be some error, but you can read what is, and then you try to catch the keywords. But there are also other way of doing these things. But what I'm trying to say, no matter, essentially it is not a given structured data like here is my income data, here is my birth data, here is my GDP data, and so just do this analysis, not like that. It's a very non-conventional data, and there is no unique way of doing this thing. There's the beauty again. It's a confusing, but beauty is that anybody can think about, whatever your knowledge is. I can think something because I have some experience of handling this type of data some way, that's what I can think. But that no way means that this is the only way to go. How? This is another one. All of you know, right? Kaggle data. Anybody has doing this thing? That the IPL, this $1 million business here. You have the records for all the teams, right? And if you can predict, you can be millionaire, right? You don't need to play in the ground, right? It's a $1 million business. Anybody has any experience? Anybody is doing here? You would see in the newspaper if anybody has done anything. These are the income hot business essentially in data science. You know that in US, predicting the basketball championship is a big thing, and the guy who does a very good job, net silver, his dad actually is MSU professor. That's the way we know it. But thing is that it's funny, he does not use actually much of the statistical tools, other than the simple statistical tables. But never he discloses what he does, never. But why we think that he does not use it? Because he did not take much of the statistics class. His dad said. His dad understood, because his dad is a political scientist. He used a lot of statistics. So just dig in and see. As I said, do whatever you understand. If you think that the mean you calculate for each of these things, and by using the mean you can do something, see what you get. Because you have now already 10 years of data, right? Or how many years, I don't know. So you can actually test some of these things. And you don't need to do this final championship even, that you might predict even some of the small pieces, like whether one team can beat one of the, like Kanpur has no team, I think. Delhi can beat Bombay, Mumbai Indians or not. Those type of things you can, but what's the probability? So typically if I have to do, I'll just calculate the probability based on the probability. I'll do that thing. So simple starting point. And we all know how to calculate the probability, and probably you will have a little bit of refreshing course from Shubhro this afternoon even starting.
Some of them know better than me.
Yeah. So that's what it will be good. So what I'm trying to say, you can calculate the probability using the data. First, see, given in a book, many of us can solve that problem because we know in the probability this is the theorem proved before, so we should apply this type of theorem. It should, but here no book is given. You have the data. you think about what the probability you have to calculate. So from the data you can calculate some of this numerical probability, and from there you can make something. But then you can try to build a model, because as the way you said, that mean can be much more accurate if you can develop a model, which I'll come later on as well. So if I can calculate the mean by using a model better way, so I should be able to calculate the probability better way if I use a model. So develop a simple model, start learning the second piece of simple model, and see whether your probability calculation changes and how it changes. So you have to do something. Okay, as I said, that there is no unique way I will be criticizing, but you do something, and that would be interesting. Who knows that you will be the next Nat Silver in IPL. Walmart recruiting, store sales forecasting. So there are 45 stores, small data set, not small, no way. You know that there are not 45, there's hundreds of Walmarts even in the United States, but data is only for 45. But Walmart sells A to Z. What is not there? Everything is there, right? You can get everything, whatever you need. Food, shoes, shirts, cycles, bicycles, camera, everything you can get. So it's a huge database. Then how do you predict its sales? Why it is making difficult? If I sell only one thing, say for example, who produce just a single thing, maybe Boeing. Boeing is producing just the aircraft, right? So I need to calculate just, although there are all different types of aircraft, but I can concentrate only the aircraft, how many aircrafts they are selling, because there is no other product. So you can actually, in terms of your whole, conceptualize the whole thing. It is much simpler. Probably one stream time series data, you can do it. But when you are doing with the Walmart, they have thousands of products they are selling. And you have to track either one way, that all of them together, which means that there is no difference, then you can actually track how much total sell. But that's the way usually it doesn't happen, because some product sell more than the other product. So really here some of the clustering technique because they have thousands of products, and you may like to develop a predictive model for each cluster wise and try to predict the sales by combining clusters again. Okay, think about, so Walmart would be happy to recruit you if you can predict some of the things. All of you know Walmart, right? This is a big retail business in the United States. Not only that, it's in other country as well. Probably in India there is no Walmart, right? There is nothing. Is there any Walmart here? No. In China there.
In Bangalore they have an office.
They have an office. That means they are doing some business with somebody here maybe.
In Bangalore definitely they have office.
Huh. So in any case, if you can do that, because Walmart is now a problem at this point, struggling with Amazon, because Amazon is online market, they are taking over. So there's lots of open problems, by the way. A little bit more complicated problems. The trending in YouTube video, statistics and comments. So can you identify the attributes that make a video popular? How do you say that which are the 200 trending videos in US and UK, or which are the 100 trending video in India? You might say, oh, I know this one, but that answer probably is right, but that's not going to help the business. Can you really produce a reliable way that this is the list of these things and this is the ranking, this is the most trending one, this is the second trending one, difference between the most trending to the second trending is this? Can you do that? These are all good problems, by the way. as I said, so you can always look at the small piece of data and then see how the way you can handle the bigger piece and then more complex. Always there is a simple way of looking the data, complex way of looking the data. Good example about the brain, I said you just look at the whole volume, then I have a one piece of data. It is easier to track. Although I lose a lot of information, but then you go with a complex nature of the data, you might get more information, it could be more precise, but you don't know how to do that. So, credit card fraud detection. Data from European credit card, can you cope up with the low incidence rate of 0.17? So in other words, you know that as much as we are doing this online business, use the credit cards, credit card fraud is a big thing. And depending on the fraud, the risk is very high. As a result, some of the credit card company might charge you more. So how do you track this thing? So that means many ways. So you first have to look at the data. But one of the data you might see, they have thousands of customers data. One piece you might be helpful if you can identify which customers' credit card are getting fraud. Okay. Then can I characterize those customers whose credit card being fraud? If I can, that's a big thing you will do. And then go ahead and see what are the purchase and when it happens. So what does it mean? That from a big data, you are just trying to identify a small portion. And that's the way you help the whole industry. So that's that's a good problem if you are in a business. But again, when you will see that the individual has tons of data, like when he purchased, where he purchased, what he purchased, how much money he spent. So thousands of variables attached for each individual credit card things. And the issue is that which one I will use, how do I use? In most old days, it was very simple because their credit, it is not really details record of what they are purchasing or anything. This is how much he paid in the end of the month, whether there is a fault, how many times he is fault in paying this thing, then it is easier to calculate. But nowadays you have so much data, so probably still you will be using the eventual information that how many times the customer has the fault over a 2 years period, over 3 years period. But instead of just calculating number of default versus not, using all these informations. So it is not simple ratio anymore. Rather than the ratio you are calculating using number of characteristic variable, so that your ratio calculation become much more accurate. Climate change, this is much more complicated problem than, but anyway, there is a data set as well in the website. Healthcare is a big thing. Data from US Department of Health on individual and small business. What drives the plan rate? Who makes the most money? You know that there is a new, I don't know here, but in United States, healthcare is a big thing. It's the most expensive thing in terms of if you are an employer and if you have to pay for their health care, it's a big liability. Rather than I will pay you the salary and you go home, it's much better because healthcare is very expensive. So very recently you might see that there are 3 big CEOs came forward, Amazon, then Chase credit card, and who the third one? Third one is the Omaha guy, billionaire, I forgot. So they 3 said that we can reduce the healthcare cost in US significantly. But how would they do that? Can you help anyway? Why the healthcare cost is very high? Why prescription drug is very high in one country versus the other country? For example, the prescription drug what you buy in India, it may be 200% more in US. Why? Okay, you might say that, oh, there is this tax, this, but that's not so simple. It's not so simple. So number of records are there, but these are good analytic problem, because the reason is that you cannot just take how much cost it take literally to buy this drug from India to bring it here, because usually there is associated all other products. It depends on the trade deal with the other countries, that if you purchase this much or if you purchase this type of items, it associated all sorts of things. So truly one item cannot be judged just one way. You have to combine many of the items, many of the factors all together, then you can get a good answer, otherwise you cannot. So, but the idea is that you take any of this data set, you do something, we'll be happy to see. In fact, I'm eager to see some of your analysis. Used car database, again this is a Kaggle data, 370,000 used cars from Germany. eBay, let's keep it simple, build a linear regression model. So what should be the price? That could be like if you are driving a car, or if you sell this car, what should be the price? That's a big thing. That's a simple thing. That says start with simple regression, see what you get, or even no regression, just do the mean and see. Then you do the regression, see how much you improve. Then do different types of regression, what we will be learning some of the things. Human resource, this is also there is data. So many things you can do whatever you like. So you guys are ready to take a data set and start working on this? Yes, do please. If you are not happy with one or any of these things, we can think about number of other problems. What do you like to solve a problem? Think those are actually already given. Probably somebody's are working. As I said that some of my students even use some of this data and trying to, but I don't think that we are there to win $1 million yet. But any other problem you like to solve? Fun problem? You can think every day you can actually the problem, every day's life problem is a data science problem. Think of it, tell me something. Vijay said that I have been talking since last 2.5 hours. You guys should say something.
Now, one thing I want to point out that data analysis means any question will also be formulated. Just a raw data will be given to you, and whatever you want you can do. Something like that.
Yeah, or you can generate some of the data. What cell phone you have? This one. What's the battery life?
4,000.
Second?
mAh.
What's the battery life?
Battery life is 1 day.
You think 1 day? Are you sure?
So based on data analysis, we say 1 day.
So can you prove that 1 day the battery life? How do you prove? So you can ask even if they have any data, and then you can do this analysis and see what the answer you get. You have only one your things, you can do your data as well. You see, first thing, there is no meaning of 1 day, in my opinion. All depends what you are doing, right? But it is not also defined. So if I can define that if it is idle, then it would go from say 20 to 24 hours, because it's no way it can happen 24 hours. So it's totally wrong answer. And also you have to say that exactly what activities you have been doing. That is also you have to specify. So what does it mean? That means if I have to be very specific about the answer, I need to associate some of the data, like my activities. If my activity is this, my mean would be this. So truly I can build a model to predict its battery life. But nobody actually does this thing, because we as a customer so far did not ask this question. Only you get very annoyed. Oh, this guy said that battery life will be 1 day. I have been traveling from here to Bombay in the Delhi 4 hours. Battery is gone. You just get annoyed, but you never even asked what is the meaning of this 1 day battery life. So you can answer this thing. Is that temperature protected? Like if I take it to say minus 20 degrees centigrade, would it work? If it is how hot it would be? Delhi, I think 45. Okay, so if I am in sauna, it would be about 70 degrees centigrade. So if I take it to sauna 70 degrees centigrade, would it work?
They have not tested, they have not given.
So look at the data. If it is not, why don't you do this project and sell them this idea? They'll be happy. Because oftentimes we don't know how to design even how to do this part. Okay, so generate some of these own questions. You can just generate small data set, try to answer this thing. And as I say, you don't need to be big statisticians to do that, but you have to have the idea how to deal the data and what this means. As I said that if I develop a regression model, I would be able to say in what sense I'm saying this thing. Right? But you guys should suggest any other data science problem. Social media data. So we talked about that, the sentiment analysis. But other things you might like, what specifically in social media you can think about. What could be your interest? Let's see.
Twitter.
Okay, what could be your interest?
Maybe in the terms of number of followers or a particular topic.
Okay. So that's actually one of my students group did their project in that class. They actually got the data from all Bollywood celebrities. So how the way the Twitter followers and the Facebook followers, how they are related. So does it matter if I tweet more? Do I have the more followers? Then I think what is the other relation between Twitter and the Facebook they were trying to do. Anyway, so there are some of the people who were interested in, and it very nice analysis they have done, because again they have to extract all this text data, unstructured data, and then but eventually what they did, very interestingly, they just did simple regression. Simple regression eventually, but at the beginning nobody had any idea that you could do a simple regression. So let me tell you one good problem, what I thought about when I was trying to plan how do I come from Delhi to Kanpur this time. So I was looking for a ticket by train. Obviously, the day when you look for, it is not available, something this. So why it is so? So we know that this is phenomena, so we cannot question, because this is the way we grown up. So question, ticket is not there, ticket is not there. But how do you, if I like to solve, because this is a very annoying thing, right? You might say that there is no solution, but there could be a solution. In Europe, generally you will get a ticket. If you buy within this range, you will have pretty good idea. Here you might say that you have a good idea if you buy 60 days ago. I don't know if that is also true or not. But suppose you like to provide a good advice to the government that people will not have any issue if you plan the network, train network like this way. What you can think about? what are the things you have to know? Because that's a good problem. Like if you can solve this problem, that people would not have really problem, or you have this problem like if you try with 1 day ahead, probability of not getting the ticket is 0.6. But if you try say 1 week ahead, probability of getting the ticket is 0.9. That would also, because eventually everything would be probabilistically, or when you're saying that 0.9, it's essentially you are giving the guarantee that they will get the ticket. But how do you make this plan? How do you give this guarantee? At this point, there is no guarantee. You really do not know when you will get the ticket or when you won't get the ticket, unless that 90 days previous, that's a different thing. But I like to know each day, because I cannot plan 3 months ahead. I like to plan every day basis. So that means if I like to take this, try to buy a ticket today from Kanpur to Delhi, what's the probability that I'll get the ticket? What should be the system work, or what the data should be in the system such that I can calculate that probability? How to interpret the probability, that's a different thing. As I said, that probably if it is a 0.9, I will interpret it is guaranteed. If it is a 0.2, I will interpret that I won't get the ticket. But how do I do that? Is it doable? Yes.
Looking at the waitlisted tickets for the last 2 months, I can sense that this much people are being denied to board into the ticket, to board into the train with their ticket. So basically, if the waitlist is long, then I can sense that yes, my probability will decrease, probability is lesser.
So that is one, is the number of waitlist in each train. That's what you have to look at. And also you have to look at how many people are traveling actually. And then that will change day by day basis, or at least month by month basis, or season by season basis. You can divide it into, again, this kind of a approximately continuous, although it is not exactly continuous, because you can do by day, but you can do approximate way like seasonal by seasonal. But what is the two, what you get that right? Two important data you say, that how many people are traveling and how many people are waiting, then what is the how many number of trains are moving, and what is the capacity of this train. If you know some, at least you should be able to tell something. But why not people are doing this simple data science and producing something? This, second?
Actually, the lack of data availability.
No, nowadays you can get, because everybody using the computer thing, not the early days that you give a counter and they just give you some ticket and there is no entry. I think everybody entering this thing in the computer.
Data has.
Every data has. So now that's what we are talking about, e-commerce. So you have seen that one of the example I said that who are generating huge data, that the e-commerce. So train data is a e-commerce data. So hugely data available for sure. And if you like to do this project with any of these government agency, I think they will be happy to have you as an intern or do something. You put the plan, I'm 100% sure they will be happy to see. But I don't think that even simple solution anybody thought about, because we are not used to. But data, why I'm trying to say, data science should make our lives much better planned. Otherwise, there is why CEOs are saying that, oh, I need to use the data, I need to use the data. So there are a number of things. Why not this thing happening in airplane? Why so much good controlled? You can actually predict in airplane, and that's why also the plane ticket price is a dynamic ticket price, but your train ticket price is not dynamic here, right? Although now, so if it is that means they have the data, because otherwise you cannot make the dynamic ticket price. Is that so? So that means there is some data, because you understand why you can do the dynamic price only when you have the data. You have a good projection about in 10 days, about in 5 days, in 6 days, everything has a good projection.
Projection is good or not, that we don't know.
But generally it should work. It should work. No, airlines models are much more well defined, because from
started with premium manner.
okay. So in any case, you guys, so there are lots of fun projects you can think about, and which might, some of the projects might turn out to be very good, and huge data is available. Okay, so I think as I said that you guys start thinking about, definitely I like to see something end of the fourth day that you guys are talking, that you have done this thing at least, so you have this, all these website informations, or you can just generate your data, whatever the way you like to do. So down the line, little disintegrated, but nevertheless already you got my sense that where we are moving. These are the kind of the general technique as I am saying, because it would be useful for many of these things, either all integrated way or just one piece. The regression is the big thing already you have seen, but I'll try to revisit the regression with you guys and see where we are. Again, I won't use much of formula for the regression, okay? I'll just go with problem solving way. And then how to do the regression model building from the classical perspective. And we already talked about that when your data becomes bigger and bigger, we call the word high dimensional data. It may be, that means your model might have lot more unknown than the sample size. So mathematically that is not solvable, which we call that big P small n problem, but you may not need to go so much of the technical details. But at least at the beginning, you, or probably by now you know that already, you need to have enough data to solve to estimate a model. But this one is essentially, will try to show that you can actually estimate a model very reasonable way, even with a small number of observations. But when I said that small number of observations, just think about, bring picture back of the gene expression data. Small number of observation means small number of individual, but total number of data points is huge. It is just in your right hand side, in your model, number of parameter increases, number of sample size is small, but total data could be still big, okay? So we'll talk about this thing. As I said that probably we will touch base on the function. If you try to think that data is actually functional, as I said, there is a number of, like the image data is truly functional data, but oftentimes you discretized. But if you really look at this whole functional way, how to look at this functional data, then spatial is this, like the climate or even the brain image, that the neurons are spatially related, like they are adjacent, so there should be some kind of correlations. If I get some time, I'll touch base. Then I don't know whether I can do this one with high dimensional, because that's the most of this part, but I think by this time you guys should be good enough to move on. And certainly we are going to talk about some of the classification technique with high dimensional, without high dimensional as well. But so then in the afternoon session, most likely it will go all this basic probability theory. How many of you know R? So you download the R and start. I'll provide you one document as well if you guys haven't used the R. You have used?
No, I have mostly worked on MATLAB.
Okay, so it's pretty simple. So I'll provide some document as well, or you can just Google it, download this R, do simple calculations, like you are calculating the event probability, this divided by this multiplied by this, calculating this matrix by matrix. Learn something, because time to time I might give you use the R for some of the other examples as well. But what is the eventual goal is that, as I said, you picked up a data, keep in mind, so at this beginning you use the mean calculation, this calculation, but you are targeting a data, or you are one of the problem that you thought about, as we talked about, you just think about any problem. End of the day, we like to hear your story, that this is the fun thing I have done. Again, we are not expecting that you will be applying all this thing, but you might conceptualize, oh, gee, I have done this portion, but possibly I might use this way. And then let's see how the way it would go. So at least what I want, that given a data, you start thinking about how to dig in the data. And then all these techniques you will be acquainted with, you do whatever after the workshop you do. That makes sense? So the question is, how do I communicate you this introduction to the R? I have a note, or if you guys are comfortable, so those who are already know, that's you can help the others, that would be lovely. But do some data, use some data set. Even two of you can pair each other, so that same data set, two of you do differently, two of you do same way, doesn't matter. As I said, that doesn't matter. Just think about that you are solving this problem. So if you are calculating a mean, then when you develop a model, you try to justify that your model based mean is better than just the mean. In what sense? So start doing this thing. So question is, can you download R or get the any document? You can, as I said, that go to the R website. It's a very good documentation, but I can share a documentation with you. But how do I do that? What should be the good way?
Share our mail ID with you or something.
Okay.
Art they can download. Art they can download easily.
Mm-hmm.
So what do you want to share?
No, so I have a R documentation.
That also available at the
So I think he wants to share one.
So no, if you guys are comfortable, that is fine. But otherwise, usually, like
And his slides.
so, like here is this just the basic introduction of R, how the way it works, some of this package, how the way you calculate. You just enter some data, and
This note is organized.
so I want you to get acquainted with, or at the end of this workshop, at least you should be able to say that, well, you can do simple statistical analysis using R. That would be at least some learning from here, right? If we don't solve $1 million problem, that's okay. You can save that problem for now, but we can solve a penny problem at this point. So this is kind of the documentation usually I share oftentimes, but since R is becoming so popular with every day it is evolving.
All of you know my email ID. Just send me your email ID. Then if you send me this document, then I can send them.
Yeah, that would be fine too. That should be fine.
That means document means are that PDF file.
That's the PDF file.
But are they can then download themselves also. So
Yes.
downloading but is fine.
Download, because you have to eventually download. There is some instruction
You
essentially.
can send me these slides also. So in that case, they can read the slides and then I give.
Okay, you want that slides, all these slides? Okay. So I'll give you these slides, but don't publicize that slides too much. Okay.
That definitely they will.
So that should be fine. All right. So far so good. All right. So I think probably you can take a break and
We'll come
but
back around 2:40, 2:30, 2:40. So all of you know basic probability. Just I want to know, or, because I will go through everything. Just I want to know whether I will go through more mathematically or just I will give the formula. That's why I'm asking. Your background is
okay. Let me spend.
That means you know little bit probability.
How about you guys?
They know everything.
They're from your department.
They know everything. I'm just telling you.
Okay. You are also from this. By the way, just for you said already you work where?
I'm alumni of IIT Kanpur.
But right now what you do?
Working with Dr. Anup Singh in Energy Analytics Lab.
Genetics lab.
Yeah, Analytics Lab.
Oh, analytics lab. Okay. Okay.
Prior, I have a work experience in a consulting firm as a business analyst.
Okay.
So now I'm working here.
Okay. How about you?
Actually, I'm still working on the same project.
Say again your name as well, although because that's my test whether I remember you or not.
My man, Mora.
Second,
Mayank. Mayank.
Mank. What is your last name?
Mayank Mora.
Maria.
Mayank Mora.
Maria.
Yes.
Okay. So you are UPite.
Yeah, I'm tech from computer science, and currently I'm working on a project which is related to some IoT thing. We are monitoring the climate of some climate monitoring system kind of thing. So we are try to save the energy by, suppose we are monitoring the temperature of the class, and if so we are using some occupancy sensors, if nobody is in the class, so we are turning off the AC, so we save the energy, and we are collecting the data continuously, so we can analyze the data, so how many times, how much energy we have saved, and how many times this thing is working well. So that's what I'm doing.
Okay. Okay. You said already.
As I told you earlier, I am working in lecturing and also working in the IT department. So related to this data only, the projects which we are carrying and trying to model all this data related.
Okay. So you are now getting too much on the data.
Yeah.
Okay.
So trying to explore various models related to the data streams and big data streams. We are learning.
Okay. All right. So hopefully I'll learn something. That's good. How about you?
I'm working under supervisor, PhD student.
Okay.
Non-parametric regression analysis.
Okay. So we'll do a little bit of non-parametric as well. But anyways, probably you can help in that case. So basically, it's a whole team. As I said, that data science means you have to work as a team. If you are thinking always you are the individual, then probably you won't be you cannot get the success. Because if I say that I understand all the neuroimage data I can solve without neuroscientist, I don't think that anybody should buy my solution. They should not. It's simple. Even no matter how good the statistics paper what I will write, probably I would, or with my that will go to the stat journal. That's right. But the solution would go to the different journal. How about you?
My name is
Deepak?
Prajapati.
Okay, you are here? Okay. Okay.
Okay, I'm telling you, just series Kiran Prajapati is working under Devashish Kundu, and then Ornov also did PhD. He already submitted the thesis. So he also did project PhD under Devashish Kundu, and that is Yas Trivedi. He is our DSMS student, and he is just looking for, I think he has already got the job, but he's also looking at
Okay.
all this in statistics. So DSMS in mathematics.
Okay, I see. All right. But as I said, still it may not help you much in terms of your PhD or anything, but probably it will help you for understanding the perspective of the data science. As you can see that being a stat professor, I'm not really talking like this is the formula stats, not the way we are starting. Here should be different. We start with the data and then see what the solution will get. But certainly some of the techniques still we have to touch base. That's what I'll do. But perspective would be still looking from the data. Okay, so if you guys think anything, we'll be happy to hear that these are the problem you've been thinking, or this is you think that this is reasonable, instead of, well, I learned this regression, then I have applied the regression like this. I think that may not be the right thing we are expecting here. So in other words, the discussion would be really good if you face some difficulties, or if you are excited with a good solution, although it's a mean calculation, but you are very excited that, well, see, this is a type of thing, nobody has done this thing. So should be okay. So I think that would be the fourth day we'll expect. But time to time we'll have provide some time to have some discussion. If you have something to discuss with everybody, again, it is nobody's thesis or anything, so you can openly discuss all this problem. As I said, you solve any of the problem, you become the millionaire. You may give me a penny, that's okay, but you discuss it, that's all right. So like the way, as I said, that the train problem or the cell phone problem, it's becoming more and more issue when people are paying more and more on the cell phone. They like to know each and everything about that part. because otherwise you have to buy protection plan for another $200. So why would you do that? All right.
So our plan is that we will come back 30 or 235, okay, and I will discuss about the basic probability. Essentially, I am teaching the ISO 201 this time in Kanpur, in this institute, so I will just follow that note, but that note is based on very quite technical. Mind you, I will read the technicalities, essentially that. Then 5 o'clock again you will come.
You can hope for, unless
4 to 4:30 is break, so 4:30 or 5 you can come and then you can discuss again your data business, all those things.
yeah. So hopefully by that time you will have. Oh, well, let's see.
And let's see. But
So-
definitely I will start from 2:30.
Yeah. So if you need more time, you can go through. That's fine, because I'm assuming that you would know a lot more on the R. So do something, but what I want that probably last half an hour or so. I come back and I like to see what you guys are doing. Our life is tough, but it's fun. Unless we do all together, it's not fun, right?